I wanted to check back with you regarding my project on testing for differences in TNF alpha levels after spinal cord injury between rats treated by a drug versus those that did not receive the treatment. What is the sample size required per your calculations?
Well, per the sample size and power calculations, you would need a total sample size of at least 30.
Okay, so I have 10 rats that I can use, and I'll extract 3 samples from each rat, and then that will give me a sample size of 30.
30 measurements from 10 rats would not meet your goal of sample size. You will need 30 independent rats.
Oh, okay. So why is that?
If you take 3 measurements from the same rat, then these 3 measurements are not independent. Those 3 measurements generated from the same rat are really technical replicates. By technical replicates, we mean multiple measurements from the same sampling unit, in your case, rats. These technical replicates represent independent measures of error that can occur in an experiment. These errors can be associated with protocols, equipment, or any other technical or experimental error. On the other hand, biological replicates are independent measures of biologically distinct samples. In your case, a sample taken from each rat would represent a biologically distinct sample.
So, yeah, there may be a day to day or a person to person variation in the handling of the samples. We try our best, but I understand that there may still be some technical variability. What I'm actually interested in is the biological differences between the two groups of rats that we'll be comparing.
Yes, so you can think about the total variation in the data into two components, biological and technical variation. The biological replicates help us model the biological variation, whereas the technical replicates help us model the technical variation. Averaging technical replicates can limit the impact of measurement error. However, taking additional biological replicates, in your case, adding more rats, is often more preferable for improving the efficiency of statistical testing.
We use very rigorous experimental protocols in our lab to minimize that technical variability that you're referring to. So, we expect the technical variability to be substantially lower than the biological variability.
So if resources are limited, it would be advantageous to use those resources to adding biological replicates. There are cases where measures of technical variability are themselves of interest. For example, to measure the effect of using different reagents or assay preparation, in which case increasing the technical replicates is more appropriate.
What happens if we do use the technical replicates to meet the sample size?
If we misinterpreted technical variation with biological variation and used it for biological inference, we would have an excess of false positives. Extremely small error bars on biological measurements may merely reflect then measurement error, not biological variation. Therefore, your conclusions really would be based on technical variability such as day-to-day conduction of your experiment or any reagent effects, not the actual effect of your treatment, which is what you are interested in.
Okay, so this was really helpful. I will now plan to generate 30 separate samples from 30 different rats.
Wonderful.